In today's lecture, we discuss the design of the biological unit processes, right? In previous lecture, we discussed the biological unit processes are classified in two types, right? Aerobic biological process and the anaerobic biological process. Then aerobic, which is again classified in two types, which is activated sludge treatment plant, and the second one which is trickling filter, and the anaerobic process which is again classified in the sludge digestion tank. Now in today's lecture we discuss the design of the activated sludge process. For that, first of all we discuss the what is the activated sludge process and how it is work, right? For that, you can see that the figure of the activated sludge process are there, right? The main aim of this process is to convert the unstable organic matter to the stable, from which is then removed by the secondary treatment, right? First of all, the microbe receive the oxygen supplied by the aeration system, right? The air pipe network at the bottom supply the air is to diffuser plate, and the diffuser plate release the air in form of the bubble, and the bubble travel upward, right? So here this is the air supply are there. After that, the sewage enter from the PST is mixed with the 20 to 30% of its own volume of the activated sludge, which contain the large amount of the microorganism, right? And this mixture is allowed to retain in the tank for 4 to 8 hours. And the wastewater into the activated sludge it's called a mixed liquor, and it is a suspended solid contained known as MLSS. It means that mixed liquor suspended solid. And the air bubble which is here, this is, you can see that the air bubble which is released by the diffuser plate and have a very small size, and therefore the contact area of air with the mixed liquor suspended solid which is increased, and the oxygen from the air is dissolved in the mixed liquor, right? Thus, the constant supply of air maintain the dissolved oxygen content enough for the aerobic microbial growth, right? Now the dissolved organic matter is consumed by the microorganism, and the number which is increases simultaneously the dissolved organic matter reduces, right? So the bioaerobic degradation of the organic matter, one of the final product is CO2. We can say that the dissolved organic matter is converted to CO2, and the bacterial cell is the ASP, right? So the other important aspect in the activated sludge process is recycling the part of the sludge from the secondary clarifier, and the question may arise naturally that for what reason the material which has to be removed from the wastewater stream is added again, right? Now, okay, here you can see that the air supply are there, and then air bubble which is traveling upward. Okay, you can see that the microbes growth in condition of the surface, and then diffuser plate are there. Okay, so this is the basic picture of the activated sludge processes. Now the next one, which is this sludge is recycled because of the following reason. The first one, which is the sludge contain active bacterial culture, right, which is in the log phase, means that they are rapidly grow and multiply, right? So such a bacterial mass gets the chance of growth when sludge is recycled, and the additional of active bacterial mass through this sludge recycle expedites aerobic decomposition. Now the position of the activated sludge plant in the wastewater treatment plant, which is here you can see that the three chamber are there. This is then PST, it means primary settling tank, it means a sedimentation tank. There is a activated sludge process, it is secondary sedimentation tank. So this is a sludge pipe are there, and the recycling activated sludge are there. They are goes to the ASP, it means activated sludge plant, after the SST. Okay, and the here from the PST you can see that the raw sludge are goes to the SDT, right? So the excess raw sludge to the sludge digester. So this is a sludge digester are there. Okay, so this is the position of activated sludge plant in the wastewater treatment. Okay, now the next one, which is the main features of the activated sludge process, which is the first of the 5-day BOD removal is around 80 to 95%, right? The second one, which is bacteria remove, may be around 90 to 95%. And for a new plant, activated sludge can be brought from other plant, or we may recycle the secondary recycling tank sludge till the activated sludge is formed, right? The recycle is most in the activated sludge processes, right? The next one, which is it needs less space, initial cost is low but high, subsequent maintenance and the supervision cost are there. Then it require a prior removal of the grid to save a aeration device from the clogging. And PST preceding the AST should have a desired SOR of 40 meter cube per meter square per day, and the detention time, which is 1.5 hour, right? Okay, so here the design consideration of activated sludge plant are given. So the first of all, we start with the hydraulic retention time. So what do you mean by hydraulic retention time? It is a ratio between the volume of tank to the discharge. Okay, now the value it is a V by Q into the 24, which is where V is equals to, we take an meter cube, then Q is equals to meter cube per day, right? Now the second one, which is the design consideration of activated sludge plant for organic loading rate, right? So basically it is the mass of BOD applied in gram per unit volume of the aeration tank per day, right? So it is a Q into Y0 divided by V, where Q is equals to discharge, then Y0, which is the BOD of influent mg per liter, and V is equals to volume of the tank, which taken into the meter cube. Now the third one, which is the food to microbe ratio. Food to microbe ratio, it means that F by M, which is daily BOD load applied divided by total microbial mass, right? Now the next one, which is it is a Q into Y0 divided by V into XT, where V is equals to volume of tank, XT, which is the average MLSS in the aeration. MLSS, it means mixed liquor suspended solid, and the lower of the ratio of F by M and higher will be the removal of BOD. Now the next one, which is the sludge age. It means that it is defined as an average time for which the particle of suspended solid remain under aeration, right? It does indicate the residence time of the biological solid in the system, and the aeration period are shorter than that is 3 to 30 hours, but the residence time of the biological solid is more than the aeration period and is measured in days. Solid are recycled and hence their residence time is more, right? So here the equation of this sludge age, which is equals to theta c, which is equals to V into xt divided by qw into xr plus q minus qw into xt, right? Okay, now the next one, which is the sludge volume index. Okay, it means that SVR. Okay, so in this step, it is the equation which is VOB divided by XOB into the 100 mg per liter per gram. So where VOB is equals to volume of sludge in meter per ml per liter, then XOB is the weight of the sludge in gram per liter, and it is the ratio of volume of activated sludge in meter cube for a 1 gram of dry weight of the sludge. And the higher value of the sludge index indicate the light sludge which take a more time in the settling. Okay, the extended aeration, it means that it is a aeration period. It is a quite long, which is 12 to 24 hours. Then this process which use the reduced organic loading, then increase the aeration time and increase the MLSS and the reduce F by M ratio. Then BOD removal efficiency is very high, about 90 to 95%. The running cost is very high and it is suitable for community having a sewage flow which is less than 4 ml. Now the advantage of the ASP, which is first is it is a better quality of effluent is obtained, then lesser land is required. Okay, the head loss is reduces. Then there is a no other nuisance are there, and the capital cost is very high. It is a high flexibility. Okay, now the disadvantage of the activated sludge plant, which is operation cost is very high, then lot of machinery to be handled, then inferior quality of the effluent, then buckling of the sludge. Okay, the quality of written sludge has to be adjusted every time, making our operation very difficult. Okay, now we discuss the design criteria of the biological unit processes. So first of all, the data which is given, it is a activated sludge plant, and the following data are that. Okay, the first of all, wastewater flow are given, right? It means that Q are given, which is 15,000 meter cube per day. The volume of tank, which is 15,500 meter cube, which is V. Then influent BOD, which is 200 mg per liter, it is Y0. Then effluent BOD, which is 25 mg per liter, which is YE. Then MLS is mixed liquor suspended solid, which is 300 mg per liter, which is XT. Then okay, effluent MLSS is means 40 mg per liter, which is XE. Then waste sludge SS, which is 1200 mg per liter, which is XW. And the quantity of this waste sludge, which is 250 mg per day, it is QW. And determine which is aeration period, then F by M ratio, food to microbe ratio, and the efficiency of BOD remover, and the sludge age in the days, right? First of all, we'll start with the aeration period. Okay, the equation which is V by Q into 24. So that is velocity which is given 15,500 into the discharge, which is also given in meter cube per day. So which is 50,000 into 24. So the aeration period, which is 7.444 hours. Now we find a F by M ratio. It means that food to microbe ratio, which is Q into Y0 divided by XT into V, right? Where the Q is given and Y0 is given, XT and V also given, right? So the Q, which is 15,000 into Y0, which is 200, and the XT, which is 3,000, and the V is equals to 15,500. Okay, so here you can see that the units are also given. So first of all, we convert into the kg per day. So here the first of all 15,000, which is given in meter cube per day. So we convert into the liter per day. Then it is a mg. So here we convert into the kg. Then again here it is given in mg. We convert into the kg, right? And the last one, which is we convert into the liter. So the final answer, which is in kg per day. So here you can see that the answer, which is F by M ratio, which is 0.215 kg of BOD per day per kg of MLSS, right? Now the third step, which is the efficiency. So the first of all efficiency, the effluent BOD minus the effluent BOD divided by the effluent BOD into 100. So the effluent BOD and influent and the effluent BOD are given, right? So the answer, which is 87.5%, right? This is okay. Now the sludge age, it means QC, theta C is equals to V into XT divided by QW into XW plus Q into QW into M. So put the value into the equation and we got the theta C, which is 9.32 days. So this is the whole design of the activated sludge plant. I hope you all understood about the today's lecture. Thank you for the watching. Thank you.